Hello student, good morning. I am Dr. A.I.I.M.S, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed question up to 298. Now I will start from question number 299. Actually these questions are tough questions, hard questions. Also you can tell brainstorming questions. Okay, these are actually numericals, and this type of numericals generally is asked in IIT, JEE, A.I.I.M.S and Neet, and because it is a tough and these questions are fit for IIT, JEE advanced level and A.I.I.M.S. This can be asked in it also, but these are hard as generally this type of question is asked in advanced level, IIT, JEE advanced and A.I.I.M.S. Now I am reading question 299. If an oxidized salt contains 1% of potassium iodide and a person takes 2 grams of the salt every day, the iodide ions going into his body every day would be approx. First option 7.2 into 10 to the power 21. Second 7.2 into 10 to the power 19. Third 3.6 into 10 to the power 21. And fourth 9.5 into 10 to the power 19. One more time I am reading the question. If an iodized salt contains 1% of potassium iodide and a person takes 2 grams of the salt every day, the iodide ions going into his body every day would be approx. First option 7.2 into 10 to the power 21. Second 7.2 into 10 to the power 19. Third option 3.6 into 10 to the power 21. And fourth option 9.5 into 10 to the power 19. Just to think, if you think in a proper way, then you will be able to solve it. Okay, just to think. Now I am giving you hint. 2 grams of the salt will contain how much this potassium iodide? 2 grams of the salt will contain how much potassium iodide? First you have to calculate, correct? Then this, it is a question, in a question it is given that salt contains 1% of potassium iodide. Means out of 100 gram salt, 1 gram potassium iodide is there, correct? Then 100 gram contains 1 gram. Then 1 gram how much? 1 upon 100. Then in 2 gram how much? Into 2. Into 2 means 2 divided by 100, that is 0.02 gram. Again I am telling you 100 gram contains 1%, 1 gram potassium iodide, because it is 1%. 100 gram salt contains 1 gram potassium iodide. Then 1 gram how much? 1 divided by 100. then 2 gram into 2, then you will get 2 upon 100, means 0.02 gram. 0.02 gram potassium iodide is there in 2 gram. Correct? Then now 2 gram, just to convert it in mole. How we will convert? Then molecular mass of potassium iodide is 39 plus 127. K is equal to 39 and I is equal to 127 iodine. Then 39 plus 127. Correct? This is the actually molecular mass. Then 0.02 gram potassium iodide is there, just to multiply by this molecular mass. Then you will get, after solving, you will get 1.2 into 10 to the power minus 4 mole Ki. Now, number of mole of Ki you have calculated. Correct? 39 plus 127, how much it will become? That you can add. Then it will be 39 plus 127, 39, 40 and this 26. 40 plus 26, okay, 66. 166. Okay, then 0.02 divided by 166, you will get 1.2 into 10 to the power minus 4 mole Ki. In that Ki, when it will dissolve in water or when it will ionize, it will give equal number of ions. Same number of potassium. Potassium and iron both will be in the same number. Correct? Means in this 1.2 into 10 to the power minus 4 mole Ki, the number of potassium ion and number of iodide ion will be the same. Then you can tell in this salt 1.2 into 10 to the power minus 4 mole iodide ions are there. Then number of mole of iodide ions you have calculated, same number. Then now it is a mole. Then now you convert into the number of ions. It is a mole. Now you can just convert in 1 mole how many ions are there. Then you know that 1 mole means Avogadro number. 1 mole is equal to Avogadro number. Then 1 mole ion means Avogadro number of ions. Then simply now you got this iodide ion is 1.2 into 10 to the power minus 4 mole. Then just to multiply by Avogadro number means 6.02 into 10 to the power 23. Just to multiply both 1.2 into 10 to the power minus 4 into 6.02 into 10 to the power 23. Then that is the, after multiplying you will get 7.2 into 10 to the power 19. Because 10 to the power minus 4, 1.2 into 10 to the power minus 4. And Avogadro number 6.02 into 10 to the power 23. Hence 4 this power will go. Now 19 will remain. Okay. Then you will get 7.2 into 10 to the power 19. Okay. Iodide ions. This is the correct. Then option which option is correct? Then question it is given this things 19.7 option B. Option B is correct. Okay, 7.2 into 10 to the power 19. Now next question I am telling you 300. Question number 300. A 400 mg iron capsule contains 100 mg of ferrous fumarate. Ferrous fumarate, that is the CHCOO Fe. Formula is given. CHCOO Fe. This is the ferrous fumarate. Then a 400 mg iron capsule contains 100 milligram of ferrous fumarate. The percentage of iron present in it is approx. First option 33%, second 25%, third 14%, fourth 8%. Again one more time I am reading the question. A 400 mg iron capsule contains 100 milligram of ferrous fumarate. The percentage of iron present in it is approx. First 33%, second 25%, third 14%, fourth 8%. Just to think it. Think it how we will solve. After that I will give you hint. Okay. Keep pen and paper with you. Now I am giving you hint. First you calculate the molecular weight of CHCOO whole to Fe. Correct? Ferrous fumarate molecular mass. Then C is equal to 12, you know, H is equal to 1 and oxygen is equal to 16. Iron is equal to 56. After adding all, because CHCOO whole 2 is there, then C12 plus H1 13, again C is there 12, 25 plus 2 oxygens are there. Then 16 into 2, 32. Add all and it is a whole 2. Hence again you multiply 2. And then Fe, add 56. Total it will become 170. Then now this molecular weight you calculated 170. Then now in this 170 gram 100 mg this iron present in 100 milligram of ferrous fumarate. How much? 56 gram. Means in 170 gram 56 gram iron is there. Correct? In 170 gram ferrous fumarate 100 this thing 56 gram iron is there in 170. Means 170 ferrous fumarate contains 56 gram iron, then 1 gram, then in 100 milligram. How much? Then 170 contains 56 milligram iron, then 1 gram, 56 divided by 170, then in 100 milligram, how much? Just you multiply by 100, you will get, after solving you will get 32.9 milligram. Correct? Then in 100 milligram ferrous fumarate 32.9 milligram iron is there. And this 100 milligram, in this 100 milligram is found in 400 milligram of iron capsule. In 400 milligram iron capsule, 100 milligram of ferrous fumarate is there. And in this 100 milligram iron you calculated 32.9 milligram. It means 400 milligram iron capsule contains 32.9 milligram iron. Correct? Then now after that the percentage you have to calculate iron percentage. Then in 400 milligram 32.9 milligram iron is there. In 400 milligram iron capsule 32.9 milligram iron is there. Then for 1, then for 100, then you will get percentage. Means 32.9 divided by 400 into 100, you multiply by 100, then you will get 8.2. Hence correct option is, in given option 8.2 is not there. 8 is there, 33 is there, 25 is there, 33%, 25%, 14%, 8%. And the nearest, and this nearest answer is 8%. Hence, option D is correct. You calculated exact 8.2, but in option 8% is there, which is close to 8.2. Hence, correct option is D. Okay. Next question I am reading 301. Caffeine has a molecular weight of 194. If it contains 28.9% by mass of nitrogen, number of atoms of nitrogen in one molecule of caffeine is: first option 4, second option 6, third option 2, fourth option 3. One more time, I am reading the question. Caffeine has a molecular weight of 194. If it contains 28.9% by mass of nitrogen, number of atom of nitrogen in one molecule of caffeine is: first option 4, second option 6, third option 2, fourth option 3. Just to think. But here I want to tell about the caffeine. Caffeine is found in tea and also found in coffee. It is narcotic substance. It affects the, you can say, mind. In little amount it will give you freshness. But if you will take in more quantity, then you will be habituated, because it affects the actually these things, mind. It affects the mind. In little amount it is good, but in more quantity it will becomes, you will become habituated. It comes under narcotic substance. It is harmless, or in more quantity it is harmless to a body, okay, particularly mind. Now again I am reading one more time question, you might be forgot. Caffeine has a molecular weight of 194 if it contains 28.9% by mass of nitrogen. Number of atoms present in one molecule of caffeine is: first option 4, second option 6, third option 2, fourth option 3. Okay, just to think. It is just if you think in a proper way, you can solve it. Okay, just to think. After that I will give you hint, but you think you fast. Now I am giving you hint. See, weight of one molecule of caffeine, that is a 194. It is a given 194. One molecule of caffeine. Then in one molecule of caffeine, how many? Actually, it is a nitrogenous compound. Caffeine has nitrogen, correct? You should remember. Then number of nitrogen atom present in one molecule, how much? Then in question, just to see, it is given 28.9% by mass. Okay, means 194 gram, milligram, whatever you can tell, or AMU. 194 contains 28.9. No, that is given this molecule. This molecule contains 28.9% by mass. Means in 100 milligram, 28.9 milligram nitrogen is there. Correct? In 100 milligram, 28.9 milligram nitrogen is there. Then in 194, how much it will be there? In 100 milligram, 28.9 milligram nitrogen is there. Then for 1, 28.9 divided by 100. Then in 194, how much? Just to multiply by 194. After solving, you will get 56 milligram or AME or gram, whatever you want, you can tell. Okay. Then 56 you got. Then now 56 is the mass of total mass of nitrogen. But you have to calculate number of atoms. Then nitrogen has 14, its atomic mass is 14. Then 56 divided by 14, you will get 4. Means 4 atoms are there. Number of nitrogen atom is 4. Hence, correct option is first option 4. Okay. Now one more question I want to discuss. Question number 302. A mixture of CH4 means methane gas. A mixture of methane gas, nitrogen gas and oxygen gas is enclosed in a vessel of 1 liter capacity at 0 degree centigrade. The ratio of partial pressure of gases is 1:4:2. Total pressure of the gaseous mixture is 2660 mm, means 2660 mm. The number of molecules of oxygen present in the vessel is, 4 option is given. First option is 6.02 into 10 to the power 23 divided by 22.4. Second option is 6.02 into 10 to the power 23. Third option 22.4 into 10 to the power 22. And fourth option 1000. Again, one more time, I am reading the question. A mixture of methane gas, nitrogen gas and oxygen gas is enclosed in a vessel of 1 liter capacity at 0 degree centigrade. The ratio of partial pressure of gases is 1:4:2. Total pressure of the gaseous mixture is 2660 millimeter. The number of molecules of oxygen present in the vessel is, first option 6.02 into 10 to the power 23 divided by 22.4. Second option 6.02 into 10 to the power 23. Third option 22.4 into 10 to the power 22. Fourth option 1000. Just to think, concept I have already discussed in theory classes. Okay, all classes, theory classes I have discussed, all concept is clear. Now just you think and solve it. You think fast because you have to solve the numericals in 30 seconds or in 1 minute maximum. And you can solve it. Your concept must be clear. Just to think it. Now I am giving you hint. Partial pressure of oxygen you have to calculate. Then ratio is 1:4:2. Means total number of atoms will be 7. 1 plus 4 plus 2, 7. Then out of 7, oxygen is 2. Then partial pressure will be 2 divided by 7. Correct? 2 divided by 7. Means in 7, 2 molecules, in 7 out of 7 molecules, you can say 2 molecules oxygen. Out of 7, 2 molecules oxygen. Then do you know that partial pressure formula? Then here what your molecules pressure partial pressure actually is given 1:2, 4:2. That is the ratio of partial pressure. Then pressure due to the oxygen gas is 2 and total is now 7. Then 2/7 into total pressure, that you know. This is the formula. Partial pressure of the individual gas divided by partial pressure of total gas into total pressure. Then 2 divided by 7 into 2660 it is given. After solving you will get 760 mm. You will get 760 mm. Then now here you have to apply your mind that 760 mm means 760 mm. This is the you can say pressure due to oxygen gas. Then 1 liter of oxygen gas. Actually all three gases are kept in 1 liter container. Then obviously oxygen volume is 1 liter. Oxygen volume is also 1 liter. Total is 1 liter, but oxygen is also present. All three gases are present in 1 liter. Then oxygen volume is 1 liter. It means 1 liter of oxygen is present at 0 degree centigrade and 760 mm pressure. Then this means this you have to consider. Then you know that 22.4 liter contains Avogadro number. 22.4 liter means Avogadro number, correct, at STP. At STP condition is given 0 degree centigrade and 760 mm. Then 22.4 liter contains Avogadro number of oxygen, means 6.02 into 10 to the power 23. Then for 1 liter, how much? For 1 liter, in 1 liter, how many molecules of oxygen is there? Just to divide by 22.4, means Avogadro number divided by 22.4, means 6.02 into 10 to the power 23 divided by 22.4. Hence first option is correct. First option is correct. 6.02 into 10 to the power 23 divided by 22.4. Today I am stopping only here. Next class again I will continue. Thank you.